a lot of folk. But its importance is, should be, I see it as a guarded importance, per se. I think there's a little too many mics on me or something. Because we have to understand exactly what's going on. And so it's critical that, that the folk here understand the science. Because the science is sort of driving what's going on now. I think science rapidly is advancing, and sometimes we don't necessarily keep up with it. We get confused sometimes. Even the scientists get confused sometimes because there's so much data. So it's important that we engage each other. It's just sad that so often I'm the only geneticist talking to folk. I don't understand why, but you know. But anyway, today we're going to talk about genetic genealogy and the ancestries of African Americans, because that's what I study. That's why I started doing what I was doing, because as an African American, I wanted to understand how DNA could be useful, a useful tool to understand ancestry, my ancestry. Why is this important for African Americans? I think this is important for a lot of communities, but African Americans in particular, because of the unique experience of Africans in America. And a recent web-based poll revealed that 80% of African Americans think that it's scientifically important to determine African ancestry through DNA testing, because as you will hear later by some of the panelists, it is difficult for people of African descent to trace their family history. It's not impossible, but there are some unique barriers that are specific to the African American experience. That experience that I'm talking about is called the MAAFA. M-A-A-F-A, or the Middle Passage, the transatlantic slave trade, the brutal kidnapping of tens of millions of West and Central Africans that were captured over a period of time early in the history of this country, and whose descendants, who themselves and their descendants helped build the infrastructure of this nation. And during that time, family structures were ripped apart. Communities lost contact with others, people in those communities. Languages were lost, cultures were lost. And so with that, family ties were lost. And so that's why it's of particular interest for African Americans to use this. So let's talk about DNA real quick. What do we know about DNA? DNA is very fascinating. I get very excited about it because I'm a geneticist. We know from the fruits and the labor of the Human Genome Project that there's like 22,000 genes in the genome. There's 3 billion nucleotides, these A, C, T's, and G's, on 23 pairs of chromosomes. And we know that because we've sequenced the human genome. Now, if we compare any two people in this room, your DNA, you'll find that there's a couple of million differences, okay? Subtle differences. And those subtle differences will lead to things like differences in eye color, hair color, skin color, body height, body weight, and also susceptibility to disease. And as a geneticist, I get excited about that because we're trying to find these genes for particular traits, normal traits, and then also for disease. We also recently sequenced the dog genome, or the canine genome, and we found that they have about 19,000 genes, the dog. And out of those 19,000, there's about 2.4 of those chemical bases that vary. 2.4 billion. On 39 pairs of chromosomes. So the dog genome is important for researchers because obviously dogs get diseases and you want to understand and just, study these genetics of these dog diseases. But we got to understand that there's only about 3,000 genes that separate us from our dogs. And that's why some of us look like our dogs. So if you look across inside the nucleus of every cell in our body, except for the red blood cell, there's DNA. And those DNA molecules are organized on these chromosomes. They're called chromosomes. And we found that men have an X and a Y chromosome here, the 23rd pair. Women have 2 X's, right? So this little Y chromosome here, this little piece of DNA, creates so much havoc in the world, if you think about it. And there's genes, in particular, important genes on the Y chromosome, like, keeping the toilet seat up and not stopping for directions. All of those are coded by the Y chromosome. Let's go back to African Americans for a second. Remember I said that African Americans in particular have this their ancestry from Western Central Africa. We know a lot about, we don't know everything, but we do know a lot about the transatlantic slave trade. Historians and anthropologists and archaeologists have worked on exploring the historical record. And if you think about it, it was a business. There were companies involved in kidnapping and shipping and selling of enslaved Africans. And so they kept records. And so you can examine those records and you'll find that from northern Senegal to southern Angola is where 95% of the enslaved Africans came from, about 5% from East Africa. So we know where, geographically, which populations may have been enslaved. But this is just a map showing the different languages of Africa. It's very rich in cultural and linguistic diversity. Thousands of different languages are spoken just in Nigeria and Cameroon alone. This area here, it's a tropical rainforest here. Thousands of different languages are spoken. There's also a lot of biological diversity. You can go to Africa, in particular West Africa, and see a wide range of skin color, hair color, and the like. So it's important to understand that there's a lot of diversity there. So when we talk about genetic diversity in DNA, and we compare any two people, we find that there are these subtle changes in the DNA. They're called polymorphisms. Poly means many, morph means forms, many different forms of the DNA. And so that's why I get excited, because we actually look at these profiles, like CSI, you know what I'm saying? And look for those differences, and we look for matches. And so, for instance, in the general population, we can look at a certain segment of DNA, and for instance, maybe 94% of you guys in the room may have a C here at this second to last position. And only 6%, instead of having a C, you may have a T, okay? That's called a SNP, a single nucleotide polymorphism. So as I said, in the room, if we compare any two genomes, there's about a couple of million polymorphisms. Those are those subtle differences. Now, some of those polymorphisms don't have any impact, but others do. Some actually contribute to disease risk, like cancer and diabetes. So if we look throughout the world, which continents have the most genetic diversity, the most diversity in their DNA, we find that African populations have the most. And that's important to understand, because African populations have been around here for the longest. So we can explore the historical record through the DNA and see that Africans as a continent have more genetic diversity than European continent or the Asian continent. In fact, half of that diversity that's in Africa is exclusive just to Africans. So if you really want to study genetics or DNA, you should study African people, because that's where the action is, huh? So why is that? Because the root of humanity, modern humans, evolved in Africa, and then they went and spread out through the rest of the world. And when they left Africa, when they migrated out, they carried with them a subset of that genetic variation. And that's why those circles in Europe and Asia are a little smaller, because they represent a subset of the diversity that's in Africa. Now, we can look and trace the migrations of people out of Africa, 100,000 into the Middle East, Europe, Asia, and the like, and then into North America by looking at certain segments of DNA. So real quickly, I'm going to place the genetics of African Americans into context, into a historical context, a social, political, and a psychological context. Because we talk about DNA, it's not straightforward. Because you can be in this room, you can say social, politically, you're an African American. But genetically, you could be a mosaic of different continental groups, okay? So here in the U.S., we have this convergence of diverse ancestries. We have people who were here before anybody else. Remember the Native Americans, Europeans, West Africans. And so we have this melting pot, which is highly polarized social political history here in the U.S. While the U.S. is this continuum of genetic variation, socially, it's black or white. You read the paper, it's black versus white. Black rates of health versus white, the economics, black and white. But we know genetically, when we talk about the biology of people in the U.S., that it's a melting pot. There's a continuum of variation. Most of this polarization in social political history is predicated on slavery and segregation. You have to define the group that you enslave as something different, right? You're not going to enslave your brother. You say, the dudes across the street, something's wrong with them. We need to enslave them. They're different. Okay, so that's where this whole black versus white slavery segregation, contribute to this polarized social political history. And then we have the anti-miscegenation laws and the one-drop rule. I find that to be quite fascinating, because in the U.S., all you have to do is have one ancestor who's black, and you're black, right? Just one. Somewhere in that family tree, and you're black, for the most part. But now things are changing a little bit. People are saying, well, I'm Cablasian, But even, and I use this as an example all the time. Halle Berry. We know that Her mother's white, her father's black, but she's black, right? I claim her as African American. I'm sure most of you would if she came in right now and sat right there. You'd say she's a beautiful black woman, wouldn't you? Wouldn't you? Of course. But half of her DNA comes from Europe. At least half. So, you have to understand this. We're talking about these social political constructs here. Genetically, she could be more European than some Europeans. So when we talk, because of this diversity in the African American population, we have some very unique features. High genetic diversity because of the antiquity of being African. The African gene pool is very old and is very diverse. The older it is, the more differences that are there in the gene pool. And then we have gene flow or admixture with non-Africans, mainly white men. And I'll get into that in a second. Don't get disturbed. Don't get upset. The pattern of variation differs geographically. So as I mentioned earlier, 95% of the enslaved Africans came from West and Central Africa, 5% from Mozambique and Madagascar. Interesting dynamics, and you look at where the enslaved Africans were brought during the period of slavery. It changed periodically, but for the most part, they were major ports of entry in Charleston. New York City was a major port, the Chesapeake Bay area, and of course New Orleans. I'm not going to get into that history, but it's a very interesting history. Very interesting history. But this is where black folk are now. This is the last census. So if you see pretty much where they were brought, these crescent states, southeast crescent states, we call here the southern mixture of states. This is where you find most of the black folk. This is the Mississippi River. This is Chicago, Detroit, New York. You don't find them out in Iowa. Unless they're playing basketball or something. Here's Oakland. Oh, I went backwards, didn't I? These are where Hispanics are. So when I talk about segregation, this is real, even when you look at it in a continental aspect. What's the dividing line? Here, Texas, right? Eastern Texas is African American, Western Texas, Hispanic, Northern Texas is white. Very interesting mix. In fact, Texas now is the old South Carolina. What South Carolina was for race during slavery, now Texas is. So a lot of issues of race are emerging out of Texas, and so it'd be interesting to watch what happens, especially politically, especially that we have an interesting president that came out of there, or two of them that came out of there. The last census, Tiger Woods was very successful in saying what? I'm more than black. So you actually were able to say you were more than black in the last census. So this is where people of mixed ancestry or mixed race, who reported that, in terms across the U.S. And you find that Oklahoma, a very large portion of folks in Oklahoma said they weren't white, or just black, or just Native American. Everybody wanted to be whatever they were and Native American. You see what I'm saying? There was a lot of things emerging in Native American politics. So it was cool. I mean, the Seminoles bought what? Hard Rock Cafe. So they went from ashy to classy overnight. So this is interesting because we talk about defining ourselves or having, somebody define us. Who's black? The answer depends on where you are. In the U.S., because of it was socially legislated by the one-drop rule or the rule of hypodescent. You are black because, as I mentioned, you have one ancestor who's black. But now everybody wants to see what else is in my genome. What else is there? This is exciting because not only could we say something about family history, but we can also say something about deep history, okay? And so there are two types of analysis, the biogeographic analysis or admixture analysis, if you guys saw that PBS special that I was a part of, where we traced Oprah's roots. And Brother Burroughs was also involved in that. And then the lineage-based ancestry, which is more specific. And that's what some of the stuff that I'm involved in, where we trace maternal and paternal lines, specific segments of DNA. One's called mitochondrial DNA, which is maternally inherited. The other one's Y chromosome DNA, which is paternally inherited, father to son. And they're very unique. They have unique features and are very informative for lineage ancestry. I'm not going to get much into this. I know I don't have that much time, but when we look at these markers, what? 1 minute? Are you serious?
2 minutes.
Okay. All right. This is a paper I wrote where we talked about the use of genetics to say something about personalized genetic history. And this is just a map showing the different maternal lineages that we know that are continent specific. Like, for instance, these L lineages are common in Africa, these in Europe, these in the Middle East and Asia. And then the founding of the Native American, the 4 major Native American lineages out of the Asian ancestry gene pool. So this is very fascinating stuff. And studies are ongoing. People are still finding new lineages because we're sampling more and more throughout the world. So the science in terms of African ancestry, informative DNA markers, as I mentioned, Y chromosome and mitochondrial DNA. We have a very large database that allows us to explore these lineages. And real quickly, I have 30 seconds, right? Let's say, for instance, we look at a mother's DNA sequence and her daughter's DNA sequence. It should be the same, right? Because, it's her daughter, right? So what we do is we look for those polymorphisms. This is in mitochondrial DNA. And we look for polymorphisms. These are those things that are different. And the son should also, because he inherits his mitochondrial DNA from his mother, he just can't transmit it on, but the daughter can. And if you look at the neighbor's mitochondrial DNA sequence, it should be different, right? Right? So here we see it's different. Most of the time it's different. So what we do is we look at this profile in that family and compare it to profiles in a database from different populations. What we do with African ancestry is actually look at a large database, a large collection of these lineages from Africa. And so, for instance, here we find a match. This is just a general way of displaying it. We find a match with the Fulani from Nigeria. And you see that those polymorphisms match, and they're different from, let's say, the Akan from Ghana or the Mandinka from Senegal. It's pretty simple. CSI stuff. It's very similar to CSI. Okay? And then you say, well, the Fulani have a very large geographic distribution. Yeah, but many of those lineages are restricted geographically to certain areas. And so the Fulani in Nigeria are a bit different from the Fulani in Nigeria. Okay? This is the Y chromosome. This is magnified 10,000 times. The X chromosome and the Y chromosome. So this little glob of DNA, as I mentioned earlier, is the Y chromosome. And there's some, as I mentioned, important genes. But we also know that since it's clonally inherited from father to son, it doesn't change. And so we can use that to trace the history of male lineages. And so this is just a tree showing the different lineages throughout the world. And real quickly, this is just my match of the mitochondrial DNA, my maternal line, in matching in Nigeria, northern Nigeria. This is from the PBS special, African American Lives. We actually tested Mae Jemison, who was the first black woman astronaut. And she had a very, very common lineage. It was very old, very, very old mitochondrial DNA lineage L1A, which is common throughout all of West Africa. So we weren't able to localize to a particular region. And that happens sometimes. It's like having a last name like Smith. Any Smiths in the room? All right, so I'm sure you two Smiths aren't related, right? That happens. I mean, you just have a common name. I go somewhere, a new city, and I open a phone book and I find a Kittles. If I do, more than likely I'm probably related to it because it's not a common name. Some of these lineages are quite common, so it doesn't mean that that they're all related. It just means that they're very old and very distant and geographically widespread. However, Oprah Winfrey had a very unique lineage. It was more recent, and it was localized to, in particular, the Capelli people in Liberia. And so she was a bit startled because she thought she was Zulu, right? Interesting story. Maybe if you ask me a question later, I can tell you about that story. But she's not Zulu. Quincy Jones had interesting matches among the Cameroon Bamileke people. And he got excited. He went online and searched about the Bamileke. He said, wow, they're musicians. I inherited the musical. I was like, yeah, okay, all right. Chris Tucker, high levels of African ancestry. I mean, he on both sides, his maternal and his paternal side, we were able to show was common in Cameroon and also Angola. And then T.D. Jakes, which I don't even have to tell you, he looks like he's some Nigerian, right? He had a match in Nigeria. All of his matches were in Nigeria, as a matter of fact, and Western Cameroon. So why study these maternal and paternal lineages? Because they are very informative. They allow us to say something about distant relatives. So when you look at this, if you go back one generation, you have two ancestors, your mother and your father. If you go back 2 generations, you have 4 ancestors, your grandparents. If you go back 9 generations, there were 912 people that contributed to your DNA. That's a lot of people, all right? And however, we can say something about your Y chromosome and your mitochondrial DNA because those came down identically through your mother or through your father if you're a male. If we go back during the period of slavery, 350 years ago, that's 14 generations. There's over 16,000 ancestors. And we can't say anything with good confidence about all of them, but we can, as I said, say something about this lineage, which is good, and this lineage. And if you know other people in this family tree, like you'll hear from Brother Chris Rabb, you can find other people to test in your family to get multiple lineages. So it is quite useful, and many folks are utilizing this service. So I'm going to end with this. This is my family tree. This is me, my brother, my sister. We actually were able to look at my mother's mitochondrial DNA lineage. She gave that to all of us. And that went back to Hausa, as I mentioned. And my mother's father's side, we had to test my Uncle Gerald for his Y chromosome. My mother didn't give me that Y chromosome. And that was Igbo in Nigeria. And on my father's side, his maternal line, Mandinka. So I was happy because I saw a Mandingo when I was young, and I was telling folks, went to school the next day. I mean, we do that. We romanticize, we make up these stories because we don't have any information. And so that's why this was so near and dear to me, because I was like, I'm going to set this up so that I can trace with some level of confidence, some level of inference in terms of where in Africa. So I wasn't lying when I said I was Mandinka when I went to school, okay? Oh, wait a minute. He's not my daddy. Don't even say that. But I put him up here because, in fact, 30% of black men, when we test their Y chromosomes, they don't go back to Africa, but to Europe. And so mine is one of them. Mine goes back, my great-great-great-grandfather was white. He was a planter in Sylvania, Georgia, okay? And you see in the South, you have black cemeteries, white cemeteries. You go to white cemetery, you see all these Kittles, and it's nicely mowed, the grass is, and there's flowers, it's real pretty. You go to black cemetery, you got to be careful because you will fall into one of those graves. It's overgrown. But I was able to find this grave where this planter who was white was buried in the black cemetery because he was messing with a black woman. Okay? He wasn't allowed to be buried with the family. So that's interesting. So this is not uncommon. 30%. In fact, I'm sure Chris could tell you something about that too. So when we look at these non-African lineages, as I mentioned, for Europeans, 30% paternal, about 5% of maternal lines of African Americans are European, but 30% of paternal lines. Native American, everybody says they have Native American. We can't find it. We can't find it. And so maybe we could talk about that further also. But this is quite interesting, and I get really excited about it. I think that I think we all need to be involved in this discussion because the science is evolving, and we really need to ask serious questions in terms of its utility, its usefulness, and its limitations. So thank you.
Thank you.